All right, guys. Here we go, guys. Let's go ahead and get started. All right. So this question that I have here is one of the questions that you guys missed in extreme numbers. I think only a handful of you got it correct. So that's why I went ahead and put it in here. So look what we have. All you're trying to do, you're trying to make this look like, like a quadratic. Perfect. I have a sine x, and what I'm trying to do is I want to get a sine squared x in there. Cool or not cool? So we already know that cosine squared x plus sine squared x, oh, it's a little laggy, probably because the laptop is hot, is 1. Cool or not cool? So I'm going to replace it, guys. So 4 parentheses, and I'm going to replace that with, let's see, 1 minus sine squared plus 2 sine x equals 3. Distribute. 4 minus 4 sine squared plus 2 sine x minus 3 equals 0. And then rewrite. Negative 4 sine squared x plus 2 sine x. Let's see, 4 minus 3 is 1 equals 0. Now hopefully you remember last year when you were in Algebra 2, this is similar to this, to a negative 4x squared plus 2x plus 1 equals 0. Yes?
Where did the first one go?
Oh, when I distribute it.
No.
Oh, 4 minus 3 is a 1. Do you see it? Now, your teacher probably told you guys that this is not factorable. We could factor it if we want to, but you would have radicals on it. It's not factorable the way that we know of here. So here's what we're going to do. You guys ready? I'm going to solve, like if you wanted to solve for x here, you would use the quadratic formula. And that's exactly what we're going to do. We're going to do the exact same thing, but instead of saying x, I'm not going to say x. I'm going to say what? Sine x. So I'm going to write sine x equals negative 2 plus minus square root. 2 squared is 4, minus 4 times negative 4 times 1, all over 2 times negative 4. How do we feel? You take your calculator. And here I am. I'm taking my calculator. Oh, let me see if I'm in tablet mode here. I take my calculator, sine x equals, and I'm going to do both. I'm going to push alpha y equals on my calculator here. And here we go. Negative 2 plus square root 4 plus 16. That's a 20 there. Negative 8. And I get negative 0.3091. That's not the only one, guys. That's for the plus. I'll go ahead and color code it. So what I just did there is that one. Let me do the one in blue. So I'm going to do the blue one in minus here. Sine x equals, I'm doing the minus one. Or the negative, yeah, the minus one here. I'm going to just scroll up. And I'm going to subtract. And there it is. 0.809. I make mistakes all the time, guys, so check my work. How do you feel so far, guys? Do we feel okay? Okay, we're not done yet. Make sure your mode is in radian mode. I think my mode is in radian mode. Yes, it is. So here we go. Which one do you want to do first, the red or the blue? Red. Here we go. X equals arc sine of negative 0.30901 plus 2 pi n. So my first equation, and I'm just going to type that into the calculator. Arc sine of negative point. I would not round it. I would use the number stored in the calculator, guys. Negative 0.309, blah, blah, blah. Here we go. I get negative 0.31415 plus 2 pi n x2. don't forget, pi minus arcsine of that same number. I guess you can write pi minus 0.31415, same deal. So x2 equals, now we'll turn it to a plus there, so here we go. Pi minus arcsine of that deal. And there's my second answer. 3.45575 plus 2 pi n. These are general equations, guys. Do we have any questions on how we got those two? Okay, you guys ready for the blue one? No? Yeah? Okay. So here we go. X equals arcsine of 0.8, bless you, 80901 plus 2 pi n. Huh? I'm just solving for the equations. In a little bit, I'll get the answers for everything. So here we go. Arcsine, and I'm going to type in that 0.80901. And I got 0.9424777 plus 2 pi n. X2 is pi minus 0.94247 or minus arcsine of 0.80901 plus 2 pi n. So x2 equals, excuse me, sorry, pi minus, and there you go, guys, 2.1991 plus 2 pi n. Okay. I don't know why I don't like those numbers, but no, we did it right. I don't see any errors. Okay, you guys ready? My solutions. What are my answers? All right, here are my answers. The very first number that I hit looks to be 0.94247. Because my domain, what's my domain? 0 to 2 pi. So 0.94247, comma, the next number that I hit seems to be 2.1991. 2.1991. The next number is this guy, 3.45575. And then the last one is from x1. Add 2 pi to it. So let me scroll up until I get that negative 0.3145. That number plus 2 pi. And there it is. Oh. 5.9690. And there it is, guys. Verify these answers, guys. How do we verify it? Yeah, graph it. Type this into Y1. Let me just do that really quick. 4 cosine x, close. I'm going to put a square on it. Plus 2 sine x. And then on Y2, I'm just going to type in 3. And then on my window, I'm going to type in 0 to 2 pi for x. And then, let's see, I'm going to go 0 to 5 for y value. Because you know it intersects at 3. Sorry that I don't have the graph on this YouTube video. Next time I'll insert an emulator in here, guys, but for now. So there it is, guys. Check it out. Second, calculate number 5. Enter, enter. And there it is. It's 3.4557, one of the answers. Yeah, it is. Let me do one more just in case. 5, enter, enter. I'm going to do the one way out here. All right, guys. Focus, focus. 5.969. Is that one of the answers? There it is. How do we feel? Okay, here we go. Let's go to the second page. All right. So here we're going to do what we learned in the last lesson. You guys ready? So remember what we did in the last lesson. We took a combined sinusoids and we turned it into one single cosine. So I have a -2 in front of the cosine. I have a 3 in front of that sine. I'm going to make my little grid. So here's my little grid. And I'm going to put a point. It doesn't have to be perfect, guys. Let's see, x, y. I'm going to say it's like right here. -2, comma 3 from the origin. There it is. Draw my reference triangle. This is the angle that I want. I'm going to use the reference to help us out. So that means this is -2, this is 3. This is my amplitude. The amplitude, square root, -2 squared plus 3 squared. Let's see what we get here. 3 squared is 9, 2 squared is 4, 9 and 4 is 13. Angle D, arctan of 3 divided by -2. And remember, the calculator is stupid. Are we in degree mode? No, we're in radio mode. Arctan, they can quit.
Wait, what does that say?
Arctan D, yeah. That's the angle that I want. For, remember this, your general equation is A cosine theta minus D. What's up, miss? Radian mode, because we're between -2 pi and 2 pi. All right. Arctan of 3 divided by -2. I get -0.98279. That's in quadrant 4, not in quadrant 2. So how do I get to quadrant 2? Add what? Not 180, we're in radian mode. Add pi. Add pi, guys. So here we go, plus pi. So now I have 2.15879, and it keeps going. Try and use as many digits as you can. So here's my equation. My new equation is square root of 13 cosine parenthesis x minus 2.15879. I wonder why it's not doing my 5 there. And all that still equals 2. So now it becomes easy. Look, I just have one single cosine. So now what do? Yeah, solve for x. Just divide by square root of 13. So cosine x minus 2.15879, that's truncated, equals 2 over square root of 13. How do I get rid of the cosine? Arc, the inverse. X minus 2.15879 equals plus minus arc cosine of 2 over square root of 13 plus 2 pi n. Since the period is 2 pi, it repeats every 2 pi. And last, you just move the 2.15879. 2.15879 plus minus find your general solution. I'm slowing down because this will be on YouTube, so you can rewind. Hello, YouTube. As soon as we're done, I'm going to upload it. If it doesn't take up too much data there. So I'm going to scroll up and I'm going to find my 2.1 whatever. So there it is. And I'm going to add. All right, guys. I'm going to add arc cosine of 2 divided by square root of 13. So here's my first one. It looks like it's pi. 3.141592653. Yeah, it's pi. Plus 2 pi n. And if I subtract, so all I'm going to do is change a plus to a minus, guys. on, run, Fido. (1.1760 plus 2 pi n). You guys ready for the answers? All right. Here we go. The domain. The domain is between negative 2 pi and 2 pi. So here are my solutions. I'm going to put it in blue, guys. So my solutions. X equals, one answer is that, 1.1760. Another answer is pi, 3.1415. Another answer, if I subtract 2 pi, so 2 pi minus pi is a negative 3.1415. And then another answer is this 1.1760 minus 2 pi. So there it is. I have it in my calculator, 1.760 already. I'm going to subtract 2 pi from it. I'm going to push enter. And there it is. So negative 5.107. I know I didn't put it in order. My apologies. And those are my answers. Hey, don't get mad, guys. No reason to be violent. See? Easy stuff, right? Yeah, don't damage the calculators. I'll delete that from this YouTube video, hopefully. All right, here we go. The good stuff. You're gonna really love this.
Okay, are we or are we?
Well, it depends. I really love it.
Okay.
I think you guys.
Everything we really love, we really don't.
Oh, that hurt me. You're trying to hurt me. Man. All right, guys. So what we're about to do is a lot of logic. We're going to derive an equation, the composite argument property for cosine A minus B. So I think this is super important for all you in the medical, engineering for sure. And I think, like, if you're going to be a lawyer, this involves a lot of logic. And I think logic is definitely what you guys need, for sure, for sure. You guys ready? All right. You guys like degree mode over radian mode, right? So I'm going to switch my calculator to degree mode. So here we go. Yes. So let's talk about what this is not. So I'm going to write cosine. And what's your favorite number between 0 and 90? A pretty big one, above 45. 63. I'm going to say that's degrees. And I'm going to choose 20 degrees. 63 minus 20 is, what's that? 63, 53, 43. 43 degrees. And if I type cosine of 43 degrees in my little calculator, I get 0.73135. 370.016. 370.16. All right, here's the most common mistake. You guys love, love, love. Yes.
Oh, okay, never mind. I'm following.
You guys love to write this. Let's see if this is true. Cosine 63 minus cosine 20. And I get negative 0.4857. Are those the same? No. So I don't know why you guys like to do that so much. So what is it not? Cosine 63 degrees minus 20 degrees is not cosine 63 minus cosine 20. Man, doesn't want to take it. There we go. Yeah, it's not. We're going to derive it right now. All right, here we go. Here we go, guys. We're going to be writing a lot. I need your A game. I need your A game. Bundis, you're going to be a medical doctor. So I need your A game big time on this. All right. Here we go. Draw a grid. Just quadrant 1. Draw the unit circle, the quadrant 1 part only. I'm going to call this angle A. That's angle A. in blue, I'm going to do a point there. I'm going to call that angle B. So then here in green, that must be A minus B. The coordinate for angle A, the x coordinate, Ms. Campbell, has to be cosine A. The y coordinate has to be sine A. The coordinate for angle B here, or coordinate B, or whatever you want to call it here, this has to be cosine B and sine B. Are we still okay? All right. What I want to figure out this line segment right there. I'm going to call this D. It's a straight linear line. And because we know we can use geometry, we can use Pythagorean theorem to figure that out. Do you guys see that? So here it is, Pythagorean theorem. All I'm doing is a squared plus b squared equals c squared. In this case, equals d squared. So I'm going to write the d squared first. D squared equals, I want the horizontal displacement down here. So that must be cosine B minus cosine A. Close it, put a square on it. That's your horizontal distance. Plus your vertical distance or vertical displacement is your sine A minus your sine B. Put a square on it. All I've done is Pythagorean theorem. Has anyone confused?
So it's okay to separate the cosine like that?
Yeah. Well, your horizontal displacement is cosine B, this guy minus cosine A, and that will give me that horizontal distance. Do you see it? Do you see it or no?
Yeah, I'm just confused.
Oh, well, you'll see right now. So here's my expression. I'm going to expand it, guys. Cosine B times cosine B is cosine squared B. And then cosine B times cosine A is cosine B cosine A. But how many of those am I going to have? So minus 2. And I'm going to put it in alphabetical order, guys. So I'm going to write minus 2 cosine A cosine B. And then negative cosine A times negative cosine A is positive cosine squared A. Then here we go. Now we're going to expand this second guy here. Sine, guys. Sine A times sine A. Sine squared A. Sine A times sine B is sine A sine B. And how many of those am I going to have? 2 sine A sine B. And then sine B times sine B. Negative sine B times negative sine B. Not everyone at the same time. Sine squared B. Are we still okay? All right. Look what we have, guys. This is going to simplify. Look what we... Yes.
Okay, I'm ready.
This right here, cosine squared plus sine squared, that's a 1. Do you guys see that? I'm going to rewrite it here. Cosine squared A plus sine squared A. Now look, I'm going to double underline cosine squared B and sine squared B. And then I just have these two do not combine. I'll just have minus 2 cosine A cosine B minus 2 sine A sine B. So now here's what I have. D squared, this is 1, this is 1. What's 1 plus 1? 2. Don't worry, I'm slowing down. Yeah.
You really aren't.
Okay, I slowed down. I stopped. Although on YouTube, it's still running. Sorry, YouTube. Give me a thumbs up, please. Minus 2 cosine A cosine B minus 2 sine A sine B. After what? Oh, okay. I will. Okay. All right. Here's what I'm going to do now, guys. We're done. We're not done, but here's what I'm going to do. Do you see this blue segment here. I want that blue segment on the x-axis. So all I'm going to do is I'm going to translate this whole, I guess you can call this triangle. I'm going to translate that triangle where this B overlaps the x-axis. Where that segment overlaps the x-axis. Cool or not cool? All right, so here's what I'm going to do. I'm going to do again the same thing. Here's my grid. And I'm going to draw the unit circle again. Yes. Equation 1. Here is the blue. And what color did I use? I used red here. So there's that blue line. And here is the red line again. And this distance here is still a minus b. So then that means this coordinate, I'm going to do it in blue, guys, a different color here. Yeah, I'll do it in blue. This coordinate is going to be cosine of a minus b, comma, sine of a minus b. Yes or no? This distance is still d. I know I didn't draw it perfectly. I should have done a copy paste maybe. That distance is still d. So here I am doing another right triangle. It's the same right triangle. I know it doesn't look the same because I didn't draw it perfectly. Do you agree that those distances should be the same? Okay, I'm going to derive my new one, my new formula. So here we go. D squared. Should I use a different color? I'll use red. Yeah, there's the second formula. D squared equals, let's see, this distance here, that point is 1 comma 0. Remember that, guys. So my horizontal displacement is 1 minus cosine of a minus b, close, squared. Plus, let's see, my vertical displacement, sine of a minus b minus 0, close, squared. I'm not insulting your intelligence. I know that sine a minus b minus 0 is just sine a minus b. All right. Sorry. All right. Yeah, it's sensitive today. I'm not sure why. Probably because of the recording here. All right, here we go. I'm just expanding it. D squared equals 1 times 1 is 1. 1 times cosine a minus b is cosine a minus b. But how many of those am I going to have? So minus 2 cosine a minus b. And then negative cosine a minus b times the negative cosine a minus b is cosine squared of a minus b. Cool? And then this guy, sine a minus b minus 0 is just sine a minus b. When I square that, it's just sine squared of a minus b. And then look at that right there. Cosine squared of a minus b plus sine squared of a minus b, what is that?
1.
Another 1, and what's 1 plus 1? 2. So here's my second equation. 2 minus 2 cosine a minus b. We're almost there at the moment of truth, guys. We're almost there. We're almost there. Are both of those d's equivalent?
Yeah.
Yes. So I'm going to write this. I'm going to write 2 minus 2 cosine a minus b better equal this one right here. It came back, guys. Let me see if I can write it. 2 minus 2 cosine a cosine b minus 2 sine a sine b. Get up to here? Yeah. Can you see?
Yes.
The one on the left-hand side is equation 2. The one on the right-hand side is equation 1. Don't worry, guys. We're almost done. Check it out. Minus 2, those cancel out. How do I get rid of that negative 2 in front of the cosine? Divide by negative 2. And finally, look what you got, guys. Cosine a minus b equals cosine a cosine b plus sine a sine b. Look how beautiful this is. And let's see if it matches. Oh, it would suck if it doesn't match. Look at that.
Okay, we did all that for formula that only the back page gave us.
But it's the beauty of it, that you know that it comes from somewhere. This is beautiful. It doesn't, no, it's not basura. It comes from somewhere, guys. What the heck is going on here? All right, so as you can see, later on we're going to derive other angles, other composite argument properties with this. But I think this is beautiful. I think it is. All right, give me 45 seconds. We're just going to use it. Oh, are you going to the restroom? Okay, yeah, go ahead. All right, here we go, guys. Do you have to memorize the proof? Do you have to memorize how we got here? No, you don't. Just know the formula. But I would like for you to appreciate its beauty, because look, all of these formulas come from somewhere. Come on, Ms. Bautista, be positive. All right, here we go. Here we go, guys. Look, all this right here, that theta is like an A, that 23 is like a B. So look, all we're going to do is just use it. 7, bracket, and look, it says cosine A, cosine B, so I write cosine theta, cosine 23 degrees, and then I have a plus there, so I put a plus, sine theta, sine 23 degrees. All I did was use the formula, guys. All I did was use the formula. Distribute the 7. I just used the formula, guys. I'm not doing anything crazy. Distribute the 7, so now I have 7 cosine 23 degrees, cosine theta, plus 7 sine 23, sine theta. The reason I moved the cosine 23 and the sine 23 is because this is a number and that's a number. I type in my calculator what that is. I'm going to go 7 cosine 23. And I'm going to push enter. And I have, let's see, 6.443 cosine theta plus 7 sine, what, say it again? Yes. Oh, that's all it goes. 7 sine 23. And I got 2.7351 sine theta. And that's it, you're done. So Chavez, what's the purpose of this? Well, guys, this right here that I'm putting a rectangle in is equivalent to that expression. If you type this into y1 of your calculator and you type this into y2 of your calculator, you're going to get the same equation. How do we feel? Is this okay? All right, guys, we're done. Well, we still have an activity, but... Why is there a what? A half? What do you mean? Let me look. Oh yeah, I haven't done it yet. It's still recording anyways. Where is there a half where? There's no half anywhere.
Oh, it says Y2.
It's a Y2, miss. Okay, LOL. Delete that whenever I get a chance. All right. Thumbs up if you liked it. Subscribe if you love it. See you guys later. Bye.